So in this short presentation, we're going to discuss the kind of research that goes into what's known as exploration, description, and theory construction ultimately. So these are different types of there are different types of research questions that you can ask when you're in a phase of research that involves the construction of theories, the construction of explanations for the phenomena that we experience out there in the real world. So much of the work that goes into theory construction is all about doing a process of what we call strengthening derivation chains. Theories are often constructed through a series of kind of derivations, and there are a number of activities that go into making sure that our theories are good by ensuring that we have strong derivation chains. So these include activities such as concept formation. So this involves the specific definition of the things that we are interested in trying to explain, or the units or the phenomena that we are including in our theory. So we may have a number of different kind of concepts that we want to explain and particularly sort of present in terms of the possible relationships that exist between them, maybe causal relationships, again, depending upon your ontological perspective as to whether you are interested in causes. But definition is of key importance when it comes to creating strong derivation chains for theories to avoid issues such as what is sometimes referred to as the jingle-jangle fallacy. That is to say that sometimes we use language and we use labels and words quite loosely, such that, for example, two different researchers could be using the same label but defining that the concept that they're using to denote that label in different ways. As such, their theories that use that concept may be referring to entirely different phenomena. Conversely, there could be two sets of or two concepts that appear on the surface to be different because they're given different labels, but actually in terms of their formal definitions are the same. Being quite explicit in the concepts that we're dealing with and the definitions that we're using are very important for ensuring that our theories are very clear about what they specify. And in fact, there's something known as the theory of concept formation, which actually treats concepts themselves as almost miniature theories which involve what are the necessary and sufficient conditions to say that a concept or that a given, for example, observation of an apparent concept has been met. We then move on to the act of determining appropriate means of measuring and observing these concepts that we're interested in our theories themselves. In order to create strong theories, we need to be able to have good means of observing and measuring potentially the phenomena that our theory refers to. So we will touch on concepts such as the validity and the reliability of measurements in a few weeks' time when we cover measurement theory itself. But needless to say, ensuring that we have good measurements and good observations are important activities involved in the theory construction process as they help strengthen the derivation chains from which we derive our theories. Now, as I mentioned as well, we're interested in having strong definitions of the concepts we're interested in because oftentimes we're interested in specifying the nature of the relationships between them. Except for in the case of concept formation in isolation, where we might refer to, as I said, the theory approach to forming concepts, which is to treat them as small theories in and of themselves. More often than not, our theories refer to a number of phenomena, a number of concepts that denote the phenomena of interest, and we're interested in specifying the relationships between them. So we might want to, linking back to measurements, think about how our concepts relate to the empirical observations of them that we make. As we touched on in the ontology lecture, we noted critical realism, and in the workshop we noted the three different domains that Roy Bhaskar referred to in his critical realist philosophy. That was the causal or real, the actual, and the empirical. So in this case, we would be specifying the relationship between the empirical world and the concepts that are referred to in the actual world, the phenomena that our concepts relate to. But we may take a step further if you take a realist view with respect to causes, and you may be interested in using causes to refer to the relationships between concepts themselves, so between different concepts. And so being able to clearly lay out exactly what our theory refers to in terms of how our measurements relate to the phenomena that our concepts denote, and how different concepts relate to one another, and potentially causally, helps us ensure that our theory is strong and makes clear what exactly it entails. Now, we will touch on this in a separate video where we will talk briefly about theory testing, but oftentimes our theories involve some kinds of auxiliary assumptions, particularly at this stage in science where we have centuries of work that has come before us. We often have auxiliary theories that go into the building of new theories for new areas. So take, for example, as I think I've mentioned before, the idea that in biomechanics research we often rely on the auxiliary theory of Newtonian mechanics in order to employ theories regarding how biomechanical factors might impact injury risk and so on and so forth. So whenever we test a theory, we don't necessarily test the theory in isolation, but we test our theory in conjunction with the other auxiliary theories and auxiliary assumptions that we make. Finally, we want to be able to engage in all of these activities so that we can make accurate predictions from our theories, or strong predictions or precise predictions from our theories. We want to know exactly what our theories deductively entail. So going back to those implicative syllogisms and the fact that we talked about the valid ones, including modus tollens, we want to be able to make statements such as, if our theory were true, we would observe something. Our theory should be strong enough in order to be able to make precise predictions about what we will observe. Now, when it comes to building theories, it's quite a creative process, and there are a number of activities which on the surface may not seem like research in and of themselves, but really are activities that many scientists engage in when they come about building their own theories. These are many activities that I've engaged in my work, particularly around the topic of effort, for example. So things like thought experiments. Einstein was well known in his development of relativity theory in utilising thought experiments, thinking about what would happen in these strange kind of extreme physical situations and how the physics might pan out and work. I've used thought experiments myself in my work in terms of defining effort. So I come up with kind of fantastical situations and try and think about the different kinds of tasks that might be used and how we might be able to apply appropriate conceptual definitions of effort in those situations to determine what might happen. Personal experiences and things like folk wisdom and folklore are also strong starting points for building of theories. Oftentimes, particularly in, again, areas like perceptual research or when we're dealing with human experience, we all kind of start from our own personal experiences of the world and the phenomena that we're interested in. It may also be that in practical and applied settings, there may be existing kind of folk wisdom. You know, in sports, for example, there are many activities that coaches engage in that kind of form a kind of coaching folklore, but they may not necessarily have kind of good reasons or good theoretical reasons for doing, but have engaged in as a matter of tradition and perhaps that they've noticed particular kind of conjunctions of patterns occurring as a result of engaging in certain things. But these can be strong starting points for starting to potentially build theories. They may also have possible explanations, and these could be the starting points for theories as well, for the development of more formal theories. Metaphors and what's called analogical abduction can also be a strong starting point. So again, I'll keep using my own work from effort as an example because it's salient for myself, but I've used analogical abduction and metaphor quite heavily in this area as well. So in my kind of conceptual definition work in trying to come up with a theory of what effort is, I've borrowed from fields such as engineering and physics and the manner in which effort is typically defined there, and tried to apply through a process of analogical abduction, which is essentially just using analogy, the definitions from there to other kinds of tasks such as exercise or sport, or even cognitive tasks and how we perform those. So analogical abduction or the use of metaphors can be incredibly valuable for this. Another field which I do some work in as well is in the field of what's called psychometrics, using something called item response theory. And this is often, which we will touch on in the measurement theory week, is a theory that's used for the development of psychological tests for measuring things that we cannot directly observe. But for a process of kind of metaphor, we can apply these kinds of models to also physical activities such as sports and things like that we can directly observe. Lastly, you can get inspiration from other fields as well, and I'd really encourage you guys to read broadly and think deeply about different topics. Read other areas of research, read other scientific fields. Even from art and literature, you can get ideas that might help inspire the development of theories. So to give another example, during my PhD, where I worked around the topic of chronic low back pain, and I worked on the idea that there was potentially a specific deconditioning of the lumbar extensor musculature that might lead to or predispose people to the development of chronic pain. I looked at specific interventions such as lumbar extensor resistance training to tackle this, but at the same time I was taking an interest in evolutionary theory, and I was taking an interest in how that might apply to the fields of exercise and health and so on. And because I was reading this other literature, it led me to think about how it might apply to my current area of PhD research. And so I ended up developing a hypothesis for how evolutionary theory might apply to the development of deconditioning and chronic low back pain, and develop that work as well. So the reading of other areas helped me to build a potential theory and explanation for what I was observing and examining in my PhD work in this kind of creative process. So, what kinds of research itself are typically done at this stage? Well, as probably seems clear, because of the creative nature of theory building and the kinds of steps that are involved in strengthening derivation chains, often research is quite exploratory. So we don't necessarily at this stage go out with some theory to work with that will help us kind of look for cases of confirmation or more appropriately, cases in which we can try to falsify the predictions that our theories make. But instead we're out there kind of like pioneers trying to explore, and we make observations, and we also potentially conduct experiments where we deliberately vary a lot of things, unsure as to which things we should focus on most, but we vary lots of things and observe and see what happens to try and help us create a kind of rich tapestry of phenomena that we can then start to build our theories from. As a result, a lot of this work falls under what sometimes people refer to as mere description. But mere descriptive research is incredibly important, because descriptive research is aimed at asking questions such as what, as opposed to why questions. We have to ask the what questions first to say what is there, what phenomena are there for us to potentially explain by using why questions. It's theories that are necessarily aimed, more broadly speaking, at the why questions, explaining why we observe what we observe, but description is aimed at the what questions themselves. There may also be kind of building on these descriptive studies what are called parameter range studies, so reaching out to the boundary conditions of some of the phenomena that we observe. So instead of just limiting ourselves to looking at the phenomena under typical conditions, we might deliberately set up exploratory research to look at extreme cases and see what are the kind of maximum and minimum values we might see for certain kinds of phenomena that we're interested in. And finally, once we get to the stage where we've got a strong derivation chain and we have a good theory, we take our theory and we change it from being a merely verbal description to something that is a bit more formal. And we can then start to use modelling studies to generate precise predictions. Particularly as theories start to become more and more complicated, it's very difficult for us in our heads to kind of look at verbal descriptions and deductively determine what the theory actually predicts. This is where things like mathematical and computational modelling studies become very, very important for determining what does this theory actually deductively entail that we should observe if the theory were true. So these kinds of research are very important for developing strong theories such that when we come to the theory testing stage, the theories are ready for that test.